Now, we began our discussion of elasticities last class. And that's really, once we know how to take 2 points of data and figure out a rough demand curve and consumer surplus, we're moving. Now we're ready to go to that next step, and that's talk about the elasticity, the price elasticity of demand, or maybe we call it the own price elasticity. And so what we're doing now, we're saying, if I'm selling a product for $100 and I sell 1,000 units every month, I wonder if it would be smart to raise my price to $115. And, well, what do I know will happen probably?
The number of units
The quantity is going to go down. And if the quantity goes down to 900 units, would that be a smart move or not? How do you tell? Check out the total revenue for starters, okay? 100,000, and then a big number.
103,500.
103,500. So what happened in this case?
You sold less, but you made more.
Yes, I raised the price. And while my quantity, of course, went down, that's the law of demand, my total revenue went up. So generally speaking, hey, that's a dang good idea.
Yeah, because then you didn't have to order as many, so you
Right.
put
Or
out
if it's hours, or I'm working, I don't have to work as many hours. When we raise the price, and as a result we make more money, that's called an inelastic demand. Now, if I had raised the price and my sales had fallen to 200, I would know that that was a disaster. And that would be an elastic demand. I'd be making less money. So with inelastic demand, and we'll define this more along the way, I know that whatever I do to price, the same thing will happen to my total revenue. And the general rule of thumb right now, this is an important one, I never want to operate when the demand is inelastic. If my demand that I'm looking at for my product is inelastic, my price is too low. I need to raise price because I'll work less and make more. You with me on that?
What did you say? Never operate when what?
Never operate in the inelastic range of demand.
Well, isn't the inelastic on that graph that you drew from the equilibrium point down to P? That puts you below your equilibrium, right?
Well, let's not equilibrium so much. We take the midpoint of the curve. The very midpoint, okay? Whatever that price is, price question mark, okay? At any price below that, that is anywhere along this part of the demand curve right here, the bottom half of the demand curve, that's the inelastic range. I don't want to operate there. If I'm operating there, my prices are too low. I need to raise my price and make more money. Generally for less work or less cost. So knowing what the price elasticity of demand is for your product, in your company, in your market, might reveal some interesting secrets. You're underpricing yourself. Okay? So, this is all about, right now, and again, this is my notation, not the book's, piece of D, the own price elasticity of demand. And regularly, we see surveys that are made by marketing and economics type people that estimate the price elasticity of demand for a wide variety of services and products. And so for whatever business you're in, you're going to get a ballpark figure about that. But you're going to want to look at your own company data to try to confirm that. We measure this. We calculate a coefficient, just a plain number. It's not in any units, not pounds, dollars, percentages, just a number. We do that by taking the percentage change in sales that occurs, the percentage change in the quantity demanded, when we see a percentage change in price. I'm going to call this good X, so we know we're talking about the same good for everything, because we'll change that later. So what do we know here? How do you find a percentage change? Well, you've got to go from one point on the demand curve to another point. So we're back to needing to know 2 points on our demand curve. Simple example, okay? When the price is $20, the sales are 100 units. When the price goes to $24, what happens to sales? They decrease, right? Because the price went up. Let's say that the sales drop to 60 units. So we have 2 points on our demand curve. How do we calculate this coefficient for the price elasticity of demand?
Yeah.
Do not try to read the formulas in any economics textbook. They are ridiculously complicated.
So
that one out.
So basically, you're suggesting, even though we use a book as a reference, don't just use yours instead of theirs.
I promise you, my way is a lot easier.
Okay.
Okay? It works this way. The percentage change in something. Let me give you an example. If I go from 6 to 10, what kind of a percentage change is that? How do you calculate that?
10
Learn that about, what, 7th grade, 6th grade? It's the change over where you started, 4 over 6, right? You would say, well, this is a percentage change. I went up 4, I started at 6. Wow, that's a 67% change. Okay so far? What if you went from 10 to 6? What percentage change is that?
1.6.
It's a change of 4. But I started at 10. Oh, well, 4 tenths. That's a 40% change. You see that? So whether you're going up or going down, you get different answers. We don't want to do that. We want to get a consistent answer whether the price is rising or falling. And so what we do is we take the change divided by the average between the two. That's percentage change in economics for elasticities. So that way, I don't care if you're going up or you're going down, you still get the same answer, 50% change. And that's good enough. So when it says percentage change in quantity, look carefully. It's the change in quantity divided by the average quantity. All of that divided by the change in price divided by the average price. And if you can remember to do it that way, it is infinitely simpler than all the permutations and garbage they put in these textbooks. So, take the data here. Use that rather straightforward way and tell me very quickly, what's the percentage change for each and what is the price elasticity of demand? Now, if you like to flip fractions around and multiply fractions, that's cool. But some of these numbers get kind of complicated. And if I could just find my calculator that I paid $15 to put on here, we can do this better. I find it more convenient just to convert these to decimal right now. 0.50 divided by 0.18. Yeah, that's enough. And these are approximate, okay? We round them a little bit. So 50 divided by 18, how much is that?
2.78.
2.78?
Yeah.
2.78. Everybody okay with the number?
Yeah, that's so much easier to go that way.
Yeah. Is this a negative number or a positive number?
It's always a negative for.
It is always negative for this elasticity. Always negative. Why? Because anytime you raise the price, positive, you decrease the quantity, negative. So you'll always have either a positive over a negative or a negative over a positive. So this is always a negative number. But because we're all educated and we know that, many times in the literature they won't put the negative on there. They assume if you're smart enough to be reading the damned article, you're smart enough to know it's a negative damn number, which is a problem. Okay? Fair enough?
Fair.
All right. So, let's go back and draw that demand curve for a moment. Straight line demand curve, axis to axis. Midpoint. This is the inelastic range. Therefore, that's the elastic range. In the inelastic range, if I reduce my price, what happens to my total revenue? It moves the same way. They both move the same way. It decreases. If I raise my price, my total revenue will rise. So if I go from A to B, I'll make more money. Here's the other thing. Let me slow down. Make sure you get your notes together. If you pick 2 points in this range and you calculate the elasticity of demand, like we were just doing, the price elasticity of demand in the inelastic range, in terms of absolute value, ignoring the negative sign, will always be less than 1.0. So if you get a price elasticity of demand of negative 0.29 or negative 0.73 or whatever, those are inelastic demand.
So anything over everything over 1.0 is elastic.
Yes, here, and again, ignoring the negative sign, absolute value, the price elasticity will always be greater than that. And if you reduce your price, you'll make more money. I didn't say profit, I said just more revenue. If you raise your price, you'll make less money. Elastic range. Okay so far? At the midpoint, or for any two prices that are equidistant from the midpoint, you have exactly 1.0 will be your elasticity, and we call that unitary elasticity. And if you go from, let's call this point A to point B, if you raise your price, what will happen to your total revenue? It won't change. And if you go from B to A, new prices, same total revenue. So you get no change in total revenue, whether price falls or price rises. Those are the basics. How are we doing? Cool. Can I erase this here? All of this is on videos and PowerPoints and stuff, and you go back and look at it anytime you need to.